Before Baldwin, Lima, and Hamilton ever signed a deal, companies were already being erased. Competitors disappeared without lawsuits, without headlines, without anyone asking questions. Well-known brands woke up stripped of their identity, answering to new leadership they'd never seen coming. Entire markets flipped ownership overnight. No warning, no public fight, no media noise. And that's the part that should bother you. Because this didn't happen by accident. It happened quietly, methodically, and always off camera. While the public watched flashy CEOs and loud collapses, Baldwin Lima Hamilton was operating in rooms you were never meant to know existed. By the time their name appeared on the paperwork, the damage was already done. You might think this is a story about growth, but it's not. It's actually about how a single whale moved through the market, swallowing smaller companies so cleanly they didn't even splash. No bankruptcies, no scandals, no warning signs. Just familiar brands quietly losing their voice, their leadership, their identity, until nothing recognizable was left. Because Baldwin Lima Hamilton didn't climb to power by inventing something new. It grew by deciding who would no longer exist on their own. One acquisition at a time, rivals became subsidiaries, partnerships turned into takeovers, and strategic alignment became a polite cover for domination. Today, the empire looks clean on paper, but beneath that polish sits a trail of mergers that reshaped industries, erased competition, and concentrated power so quietly that few people stop to ask the real question. At what point does expansion stop being strategy and start being control? Baldwin Lima Hamilton emerged at a moment when reputation had stopped protecting manufacturers. The company took shape at the intersection of three industrial identities that had dominated their fields for decades. Baldwin Locomotive Works with its sheer production muscle, Lima Locomotive Works with its engineering prestige, and Hamilton Engine Company with its diesel discipline. Each arrived at the merger carrying strengths that once guaranteed market control and weaknesses the industry no longer forgave. This collision did not happen because the companies shared a vision of the future. It happened because the future had already arrived without them. Baldwin operated on volume and legacy. Its business model depended on long production runs, standardized steam designs, and customer loyalty built over generations. Lima operated on refinement. Its engineers chased performance gains through thermodynamics, combustion efficiency, and sustained horsepower. Hamilton operated on durability and precision, designing diesel engines for environments where failure carried consequences measured in downtime, not prestige. These cultures never aligned naturally. They were forced together by timing. By the late 1940s, procurement officers stopped asking who built the most powerful steam locomotive and started asking who could guarantee uptime, fuel savings, and predictable maintenance schedules. Steam manufacturers found themselves defending a technology railroads had already decided to abandon. Railroads did not reject steam out of sentiment or aesthetics. They rejected it because steam demanded labor, water infrastructure, constant inspection, and specialized crews. Diesel-electric units arrived offering smaller maintenance teams, faster turnaround, and cost models executives could explain to shareholders without footnotes. Contracts began flowing toward diesel suppliers with integrated systems, engine, generator, controls, and service support bundled together. Baldwin and Lima watched order books thin while their competitors expanded production capacity elsewhere. The industry conversation shifted from mechanical excellence to life cycle economics. Steam builders spoke the wrong language at the wrong time. Dieselization functioned as an economic filter. Manufacturers either adapted quickly or lost relevance. Baldwin experimented with diesel platforms, but struggled with electrical integration and consistency. Lima possessed engineering brilliance, yet lacked diesel infrastructure at scale. Hamilton understood diesel engines intimately, but lacked market reach on its own. Individually, none of the three could compete effectively against vertically integrated diesel suppliers. Together, they offered scale, expertise, and manufacturing capacity, at least on paper. The merger offered time to stabilize finances, time to defend remaining contracts, time to appear competitive in a market that increasingly valued perception of capability as much as capability itself. Publicly, the merger was presented as a strategic alignment of complementary strengths. Press releases emphasized efficiency, expanded product lines, and a broader technological foundation. Customers were assured continuity, investors were promised resilience. Privately, the merger served as damage control. Facilities overlapped, engineering teams carried conflicting priorities, product strategies reflected compromise rather than clarity. Decision-making slowed under layers of inherited management structures. Unity existed in name and ownership. Operational harmony lagged behind. Baldwin Lima Hamilton represented consolidation as survival strategy. The merger reduced competition without solving every technical challenge. It centralized patents, absorbed skilled labor, and preserved customer relationships that might have otherwise disappeared. This approach stabilized the company short-term while exposing a deeper problem. The market no longer rewarded legacy engineering dominance. It rewarded systems thinking, service networks, and predictable cost models. BLH stood at the crossroads of industrial history, powerful enough to delay decline, constrained enough to struggle against momentum already moving elsewhere. The question left hanging after the merger was never about whether Baldwin Lima Hamilton could survive. The real question was how long survival could substitute for reinvention. Baldwin Locomotive Works entered the Baldwin Lima Hamilton merger as the largest name in the room. For more than a century, Baldwin had defined locomotive manufacturing at industrial scale. Its production capacity dwarfed competitors. Its customer list spanned continents. Governments, railroads, and private operators associated the Baldwin name with authority, durability, and sheer mechanical force. Baldwin's factories had produced steam locomotives in volumes few manufacturers could even attempt. From freight haulers to passenger power, Baldwin machines carried the weight of empires, wars, and national expansion. The company mastered boiler construction, heavy castings, precision machining, and valve gear systems refined through decades of iteration. When railroads demanded raw pulling power, Baldwin delivered with confidence. That dominance shaped Baldwin's blind spots. Baldwin engineers optimized steam systems to a degree that bordered on specialization at the expense of adaptability. Metallurgy choices favored high-pressure boilers. Shop layouts prioritized massive cast components. Labor structures revolved around steam-era skills that took years to train and replace. Diesel-electric locomotion demanded a different mindset entirely. Electrical systems had to operate as tightly integrated units rather than as supporting accessories. Engines functioned as modular power plants rather than bespoke mechanical assemblies. Maintenance shifted from mechanical overhaul cycles to predictive service intervals and component replacement. Baldwin's internal processes resisted that shift. The company carried steam logic into a diesel market that punished inefficiency and inconsistency. Baldwin's early diesel-electric efforts struggled to gain trust. Reliability concerns surfaced quickly. Electrical equipment partnerships failed to deliver uniform performance. Locomotive models varied too widely, complicating maintenance and parts supply for customers already comparing Baldwin offerings against cleaner, standardized alternatives. Railroads calculated risk with growing precision. Breakdowns carried operational costs that steam-era reputations could no longer offset. Procurement officers remembered missed delivery timelines, inconsistent electrical systems, and service complexity. The result appeared quietly in order books. Contracts moved elsewhere without public confrontation. Baldwin's name carried expectations formed in a different era. Customers expected leadership. What they encountered instead felt transitional, cautious, and uneven. In a market shifting rapidly toward diesel standardization, hesitation read as weakness. Scale, once Baldwin's greatest advantage, slowed response time. Large facilities could not pivot overnight. Management layers diluted engineering feedback. Legacy production commitments consumed resources needed for experimentation and refinement. Prestige delayed urgency. By the time the market made its verdict clear, recovery paths had narrowed. Baldwin arrived at the Baldwin Lima Hamilton merger holding unmatched manufacturing capacity and deep technical knowledge, and facing shrinking relevance in the market that once sustained it. The company needed partners not to expand dominance, but to arrest decline. Size provided leverage, reputation provided breathing room. Neither guaranteed long-term survival. Within BLH, Baldwin became the anchor, powerful, heavy, and difficult to redirect. The merger offered Baldwin shelter from immediate collapse, while exposing the cost of relying too long on yesterday's supremacy. Lima Locomotive Works entered the Baldwin-Lima Hamilton merger carrying something Baldwin lacked and the market no longer rewarded: forward-leaning steam innovation. Lima engineers approached locomotive design as a performance problem rather than a production problem. Their work focused on sustained output, thermal efficiency, and real-world operating conditions instead of headline tractive effort numbers. The superpower concept became Lima's signature contribution to steam evolution. Larger fireboxes, increased boiler capacity, improved draft, and higher sustained horsepower allowed locomotives to move heavy trains faster and over longer distances without the frequent stops that defined earlier steam operations. On paper and in service, the results impressed engineers and operating crews alike. Lima solved problems steam was no longer allowed to have. Lima's design philosophy assumed steam would remain central to railroad operations long enough for efficiency gains to matter. That assumption collapsed quickly. Railroads faced labor shortages, rising fuel costs, and mounting pressure to modernize operations. Diesel-electric locomotives offered immediate reductions in crew requirements, simplified servicing, and predictable availability. Superpower locomotives reduced some steam inefficiencies, but they did not eliminate water stops, ash handling, boiler inspections, or specialized maintenance infrastructure. The improvements addressed performance, not operating economics. Railroad executives noticed the distinction. Lima locomotives earned respect inside mechanical departments. Engineers studied their boilers, designers borrowed concepts, crews praised their performance. Meanwhile, procurement departments signed contracts with diesel suppliers capable of delivering standardized fleets supported by service agreements and financing packages. Admiration did not convert into purchase orders. Lima found itself celebrated in journals and sidelined in negotiations. Technical superiority carried weight in workshops, not boardrooms calculating long-term cost exposure. Unlike Baldwin, Lima lacked scale. Unlike diesel manufacturers, Lima lacked vertical integration. Its customer base narrowed as steam orders declined across the industry. Each contract carried higher stakes. Each delay amplified financial risk. Lima's bargaining position weakened rapidly. Brilliant designs could not compensate for shrinking leverage. Without the ability to dictate market terms or absorb losses, Lima stood exposed. The merger offered protection through association rather than expansion through demand. With Baldwin Lima Hamilton, Lima's legacy shifted from product leadership to intellectual influence. Its engineering culture shaped boiler theory, airflow management, and performance metrics that influenced thinking even as steam faded from relevance. Lima arrived with solutions refined for a battlefield already abandoned. The company did not fail because its ideas were flawed. It failed because the industry stopped asking the questions Lima knew how to answer. Hamilton Engine Company entered the Baldwin-Lima Hamilton merger without spectacle and without nostalgia. Its reputation formed in environments where engines were judged by hours logged rather than headlines earned. Marine operators, industrial plants, and stationary power customers demanded reliability, predictable maintenance, and conservative engineering margins. Hamilton built engines for that audience. This focus positioned Hamilton closer to the future than its louder partners. Hamilton engineers approached diesel engines as long-duration assets. Design priorities centered on controlled combustion, robust fuel injection systems, thick section castings, and stress limits well below theoretical maximums. Operating RPM ranges favored longevity. Cooling and lubrication systems were sized for sustained load rather than peak performance. These engines were not designed to impress, they were designed to run. Post-war industry rewarded exactly that philosophy. Power generation facilities required engines that could operate continuously. Marine propulsion systems demanded reliability in environments where failure carried logistical and financial consequences. Industrial customers measured success in uptime and service intervals, not innovation cycles. Hamilton spoke that language fluently. Hamilton's manufacturing culture differed sharply from steam locomotive production. Precision machining, tight tolerances, and repeatable assembly processes formed the foundation of its operations. Engines were modular enough to simplify maintenance, yet conservative enough to avoid unexpected failure modes. This approach translated directly into customer confidence. Hamilton engines earned reputations for durability rather than experimentation. Operators trusted them under constant load because their design assumptions favored predictability. Within the merger, this discipline stood in contrast to the broader uncertainty surrounding steam and transitional diesel locomotive programs. As railroad steam declined, Hamilton-powered products expanded quietly. BLH engines found homes in marine vessels requiring continuous duty cycles, stationary power plants supporting industrial infrastructure, and compression and pumping systems operating around the clock. These applications generated steady revenue, while locomotive orders thinned. Unlike railroads, these markets valued incremental improvement and long-term service relationships. Hamilton engines fit neatly into that ecosystem. The merger amplified Hamilton's reach without forcing its engineering philosophy to change. Despite its central role, Hamilton rarely shaped BLH's public identity. Branding favored locomotive heritage. Marketing leaned on names associated with steam-era dominance. Internally, Hamilton engineers supplied solutions while others debated direction. This imbalance mattered. The division most aligned with market demand held limited influence over corporate strategy. Hamilton provided BLH with relevance in a post-steam economy. The company kept the enterprise mechanically credible while other divisions searched for purpose. Hamilton Engine Company functioned as BLH's stabilizing force. Its engines delivered reliability when uncertainty defined the broader organization. While steam-centric operations struggled to justify their place, Hamilton-powered systems operated quietly, predictably, and profitably. In a merger shaped by urgency and reputation, Hamilton contributed something rarer than legacy or invention. It contributed endurance. The BLH merger did not result in a clean synthesis of cultures. Facilities remained fragmented. Engineering teams retained legacy habits. Product lines overlapped and competed internally. Decision-making slowed under corporate complexity. What the merger achieved efficiently was control. Control over patents, control over supplier relationships, control over skilled labor, control over remaining steam-era customers. BLH gained negotiating power simply by removing alternatives from the market. Customers faced fewer choices, vendors faced fewer buyers, engineers faced fewer employers. This was not organic growth. This was industrial gravity pulling weakened giants into one mass. As locomotive orders declined, BLH pivoted toward engines as standalone products. Diesel engines for ships, power plants, military applications, and industrial facilities became the company's most defensible assets. Hamilton designed diesels powered marine vessels requiring continuous high-load operation, industrial plants demanding reliability over innovation, military platforms prioritizing serviceability. BLH engines earned respect for robustness rather than elegance. These machines favored conservative RPM limits, thick castings, and service-friendly layouts. Engineers trusted them because failure margins were generous. This segment kept BLH relevant long after steam disappeared from mainline railroads. BLH's scale created internal inertia. Competing priorities diluted focus. Diesel competitors refined platforms faster. Electrical integration lagged behind industry leaders. Customers noticed inconsistency between divisions carrying the same logo. By the time BLH streamlined operations, the market had moved again. General Motors, Alco, and emerging global manufacturers understood systems integration better. Engines, generators, controls, and service contracts offered as unified packages. BLH still operated as merged entities, sharing letterhead rather than a unified machine. BLH stands as a case study in merger-driven survival. It demonstrates how industrial empires can delay decline through consolidation while exposing new weaknesses created by size and complexity. For engine specialists, BLH represents a transition point from steam dominance to diesel realism, a reminder that engineering excellence alone does not secure markets, and proof that control and capability are not the same thing. The BLH empire rose by absorbing strength from others. Its legacy forces a hard question for modern industrial giants. When markets shift faster than engineering culture, does merging buy time or simply slow the fall? Baldwin Lima Hamilton proved that empires can be assembled faster than they can be unified. Steam power, engineering brilliance, and diesel discipline collided under one name, yet the market only rewarded what aligned with the future. The merger bought time, not certainty. What remains is a hard industrial lesson written in steel and cast iron. Consolidation can delay decline, but only adaptation decides who survives when technology moves on.